Okay, so example number 1 here. Again, this is maximum height, and this is throwing an object upward. Okay, so as the problem states, Mason hits the soccer ball off his head at 64 feet per second from a height of 8 feet. At some point, I'm going to give you that reading material, but I will not give you the equation at the end. So you're going to have to know where these things come from. Number 1's equation will always say h of t equals negative 16t squared. And then it'll be plus the velocity. So here you know it's the velocity of 64 because it says feet per second. That is the speed. The height is at the end of there. So it's the plus 8 because it is hit from his head at a height of 8 feet above the ground. Okay. To begin here, you're going to identify the values of A, B, and C in the standard form. So A here is negative 16. B here is 64. And C is 8. Then to begin the actual work here, you're going to actually find the axis of symmetry first. So I'm going to put AOS. And then I'm going to write the equation T equals negative B over 2A. You'll remember that in the bell work it said X equals negative B over 2A, but that's because the variable in the equation on the right hand side was X. Here note that it is T, so it should be T equals. However, if you put X, that would be okay. I would not count off. Okay, so the opposite of B, the opposite of 64 is negative 64 over 2 times A, or 2 times negative 16, which gives me negative 64 over negative 32, which is equal to a positive 2. From there, we're going to create a table of values. I'm going to call this an H table. And in the H table, I'm going to put my T values over here on the left-hand side. In the middle, I'm going to put the actual equation that I'm working with. Make sure that it's the equation that you're working with and not something from a different problem that you're watching or from a different assignment. So this is negative 16t squared plus 64t plus 8. And at the end here, this is going to be the ordered pair. This is t, which is what you're plugging in, comma h of t, which is the value in which we get back out. Okay. All of these problems are going to start here at the top of the graph or the table, and you're going to plug in 0. And we're going to plug that in and continue to work it out each time we go up. With these problems, my suggestion is to go up by 1 and then evaluate it. If you reach a 0 output or a negative output, you're going to stop. You may at some point have to break this down to further decimals. However, most of the time what I'm going to do is give you something that you can increase by just 1s. Okay, so number 1 here, you're going to plug in 0, which means I'm going to have negative 16 times 0 squared plus 64 times 0 plus 8. When you work that out, you plugged in 0, comma, do the order of operations properly, remember PEMDAS, and you should end up with 8 back out. Okay. We're then going to continue, and as I said, we're going to continue by 1, so we're going to go to 1 next, and we're going to plug it in. Negative 16 times 1 squared plus 64 times 1 plus 8. Again, you're going to plug that in. You're going to get 1 comma 56. And then you're going to make sure that you plug in your axis of symmetry. So here, note that axis of symmetry is 2. So if I continue to go by 1s, that's actually the next number that I'm going to hit anyway. However, if this was a decimal, let's say something like 1.5, then I would put 1 here, and then I would go 1.5 and then I would go to 2. Okay, but the axis of symmetry has to be in the table. So here I'm going to put this in blue because that's the color that I use for axis of symmetry. I'm going to have 2 here. I've got negative 16 times 2 squared plus 64 times 2 plus 8. When you work that out, you get 2 comma 72. And then we're going to continue. Number 3. I got negative 16 times 3 squared plus 64 times 3 plus 8. And that's going to give me 3 comma 56. And then we're going to continue to 4. It's negative 16 times 4 squared plus 64 times 4 plus 8. Which is going to give me 4 comma 8. We're still not at 0 or a negative number here, so you're going to have to continue. Go to 5. You get negative 16 times 5 squared plus 64 times 5 plus 8. And that should give you 5 comma negative 72. Now that we've received a negative value, you're going to stop the table and then start your other work. Okay, you're going to have to create the scale on the graph. In order to do that, you're going to use information from the table that you just created. Okay. I'm going to create the h of t scale here first. That's the y-axis. The corner here is obviously going to be 0 because this is the origin. Okay. The h of t scale we're going to use the value that comes out for y in the event of the axis of symmetry being plugged in. If you have a decimal, be sure that you plug in the entire decimal. Do not round it off. I want it as holistic as possible. So if you have to leave it as a fraction up here to plug it in nicely into the equation, then do so. Okay, but here we have 72. I'm going to divide that by 4. And I'm going to divide that by 4 because if you look close at the graphs that I provide you, you have 4 nice landmarks here. Okay, that divide this big graph into big sections. Okay, so I'm going to divide that by 4. When I take 72 divided by 4, I end up with 18. My suggestion for these, if you look closely again at these graphs, I have 5 jumps between each of these darker black lines that I just created. And in order to find out how to go by each line, it'd be nice to have something that I can divide nicely by 5 and have a whole number to work with instead of a bunch of decimals. So I'm going to take this h of t scale and I'm going to round this up from 18 to 20 because that's the next thing that's a set of 5. So I'm going to round it to 20. Okay, and in doing that, that's going to give me here 20. 20 plus 20 is 40. Plus 20 is 60. Plus 20 is 80. Okay? In order to find out how much I have for each jump now, I'm going to start with this number. I'm going to divide it by 5. Because again, I have nice little jumps here between. So 20 divided by 5 is 4. So that means that each line continuing up stands for 4 units, or 4 feet above the ground. On the other side here, I'm going to work out the t scale, or the x-axis scale. The t scale on problems like number 1 is going to be based off of this very last number on their table. You're going to take whatever value here gives you a 0 output or a negative output. And I'm going to take that value and I'm going to divide it by 6. Okay? And I'm going to divide it by 6 because, again, similar to what we did over here with the landmarks, I've got 6 landmarks here. I have a darker line here, 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 and at the end. Okay, so this is going to give me 0.83 repeating. Again, I'm not trying to work with a lot of decimals, so I'm going to take this decimal value and I'm going to round it up to the nearest 1. You could round it to a half. That works out kind of nicely at times, but for this purpose, we're going to round it to 1. Okay, so we're going to round to 1, which gives me 1 here, 2 here, 3 here, 4, 5, and 6. After that, you're going to then plot your points. So we have 6 ordered pairs, 5 of which that we can actually graph. Okay, so again, keeping in mind that this is what we're graphing, and that each item here, each line goes up by 4. So I have 0, 8 first. I'm going to go to 0. I'm going to go up to 8 and make a dot. All right. For some of you, my suggestion would be this. Instead of going blank spaces like I have here, some of you may want to actually fill them in. So write 4, and then 8, and then 12, and then 16, and go all the way up if you need to. But again, be your own advocate. If you don't need to, that's fine. Okay. 1, 56, so we get a 1, 40, 44, 48, 52, 56. 2, 72, I have 2, 60, 64, 68, 72. 3, 56, so I have 3. I go to 40, 44, 48, 42, 56. 4, 8, so I go to 4, 4, then 8. And then again, 5, negative 72, I can't graph. Okay? So as best as I can, I'm going to come back to this first dot that I created, and I'm going to graph a nice smooth line that transitions and connects all the dots. Okay. It's important here at the end that you don't just stop and go straight down or curve crazy out, because I see that happen a lot. Again, this is a nice smooth curve that transitions as smoothly as possible. Sometimes you may want to take your paper and turn it to the side. So take this, turn it so that you can create a C more than kind of an N. Okay, it's a little bit easier for some people. Then we're going to identify some things here. I'm going to put a dashed line where the axis of symmetry is. So again, my axis of symmetry is at t equals 2. So here at t equals 2, I'm just going to come through and do a dashed line all the way down, and label this as x equals 2. Okay, that is my axis of symmetry. And the purpose of an axis of symmetry is that I can pick this paper up on top of that line and fold it right across that line, and then these dots should kind of fold over and match up exactly. In this problem then too, to finish this up, you're going to have to identify 3 things and tell what they mean in reality. In the context of the actual problem, what do they actually mean? So the first thing is my x-intercept or my t-intercept. My t-intercept is right here. Okay, so t-intercept. And here, this is between 2 values. I don't have a nice ordered pair, so I'm going to list a between statement. It's going to be a math statement. It's not going to say between, but you're going to put whatever this value is here on your scale. So 4 is less than t, which is less than 5. Okay. The question is then, what does that actually mean in relation to this problem? That means that the object, or the soccer ball here, has now hit the ball hits the ground between 4 5 seconds. The h of t intercept here stands for what? Okay, this is 0, 8. The nice thing with this is the h of t intercept will always be your first ordered pair here in the table. If it's not, you should have put that. Okay, so this is your very first order pair. Again, it's always 0, whatever the number is, all right? And it should be always 0, whatever the last number is if it is in standard form. So 0, 8, what does that mean? That means that this is the initial height. Okay, when this object hit off of Mason's head, or when this object hits off of whatever person's bat, foot, neck, whatever it may have hit, that's the point in which it bounced off of them or that thing. Okay, the last thing to find here and identify is the maxima, and the maxima is coming from the vertex order pair. You will find your vertex from the table, and it's when you plugged in your axis of symmetry. Again, it's highly important that you plug in that axis of symmetry exactly as it should be. Do not round off a decimal if you have a decimal. Okay, so the maxima is just the y value. It's not the ordered pair here, it's just the y value. So we have 72 feet in this problem is the maxima, and that is the highest the ball will go. Okay, eventually the ball is going to go up, and the gravity's going to say, okay, it's time to come on back down, and then it's going to start falling down. Okay, and that happens at 72 feet here. Okay, and then once you have that done, then that's all you have to do for number 1. Again, I get that it's a lot of work, but it's doable. The more you do these problems, the easier it's going to get. So try, do a few steps, verify with me, and then try a little bit more. Okay, never give up.